seen, they are viruses that are classified based on the payload they execute and the way how they execute their payloads, their payloads. But in all cases, they are classified as viruses. Why? Because they act without consent. They are hidden and they try to cause some of the damages to the environment they are in. And the damages we discussed some. They conceal, they hide, they infect. Okay, the second category of the malware is the worms. This kind of malware is still it's a computer program. It has to execute a payload at the end of the day, and those Bothaina is coming. Why are you coming late? Bothaina, why are you coming late? Okay, the main purpose behind of the payload that the worm do, and because of it, it is nominated the worm, is that it infects the computer in order to make it be remotely controlled. In the sense of we are having a malware injected into a computer, and this malware is allowing the victim to be controlled by an attacker remotely, no more, no less. Besides of that, the worms actually they do infect an environment. They do not infect only a computer. They travel by themselves from a computer to another within a given framework, within a given computer network. So they are more disastrous than the viruses. Worms actually, they are, as I said, they travel by themselves to the environment. They do not stop at a single computer. If there is a connectivity to the external world, they will use it. The worms by themselves, they do not wait for any action from the user. They do not wait for any behavior, event handler to be launched or something like that. No, by themselves only. They do travel from a device to another, and they do not need to be attached. They do not need to be attached to an email or to a message to be sent. They by themselves only they travel. They are traveling as a standalone computer program. Some comparison between a virus and a worm. Some comparison what they can do, what they cannot do. Okay. Trojans, these are another category of malware, the third category of malware. See, we are talking about only about computer program only. Yet the Trojan actually it is a sort of a computer program that intends to be or tries to present himself as a positive computer program that does actually what the user is expecting. Yet at the reality, it is not. It is hiding a malicious code in background to be executed once it is inside the environment. So it tricks the user to get access to an environment, and once accessed, actually they will do what the user did not expect. They will yes execute their payload, no more no less. From the categories of the Trojans, also from the categories of the malware that we are able to classify as a very catastrophic and disastrous malware, the rootkits. Those are sort of computer programs that they infect the motherboard of the computer or the digital device. Those rootkits, those are actually computer programs. The presence is something completely hidden from the end user. It does not show anything, but they are going to change the full operating system behavior. Since they are infecting the motherboard of the computer, they are infecting the hardware, the controlling unit of the hardware, the BIOS and the CMOS. And because of that only, they are able to change the behavior of the operating system. Behavior of the operating system is going to be changed in the sense of regular commands an operating system do, and if the computer is infected with a rootkit, those commands they would be actually altered. What you are expecting to get it will not be terminated or accomplished due to the infection with the rootkit. It is not easy to detect. It is not the role of the antivirus or any security appliance installed on top of the operating system to detect a rootkit. No. Answer is no. Because this malware is attached to the motherboard. It is to the layer down the operating system. It means the antivirus or the security appliance installed on top of the operating system will not be able to see this kind of rootkit. There are methodologies, there are techniques can be applied to detect if there is any rootkit installed or if there is any rootkit available in your motherboard or in your BIOS and CMOS firmware. But it is not easy to detect it, this is for sure. And beside of that, we are talking about detection here. But beside of that, once detected, for example, we reach to recognize that a given computer is infected with a rootkit. Can we rectify that? Can we find a cure and delete the rootkit? 99.9999999%? We not. You not be able to take off a rootkit because it is controlling the microchips, group of microchips, controlling the motherboard. It is not a file to delete. It is not one file to delete. So the process of this rootkit is extremely to be concealed, deleted, eliminated. It is extremely difficult. It's not difficult, it's extremely difficult. So almost no, and it is no. Rootkit, remember this name. Okay, from the examples of the rootkits, actually, whatever, there is a scenario that the Microsoft has discussed and has found a solution for that, and this is seen in the rootkit revealer that the Microsoft has generated. Rootkit revealer, it's one of the technologies that it's a software, it's a computer program, but the Microsoft has generated that would detect if a system is already infected with a rootkit or not. So only to see the evidence if there is any rootkit on the computer or not. Rootkit revealer. Did we finish and did we explain this part actually last class? Imam Rashid, did we explain this part?
No.
Okay, great. We continue. Logic bomb, because I thought that we explained that. The logic bomb is another kind of a malware. Still, it's a computer program only. And this computer program, actually, it is given the name logic bomb because it deals with the chronological control to execute the payload. It's a computer program, but it is classified as a malware, and it is given the name logic bomb because it deals with the chronological timing clock from the computer, and based on the time, it executes its payload, which is the bomb. It is said a bomb. It needs a trigger to execute, and the trigger is the time, mainly, not only. And once the time comes, the bomb is the execution of the payload. The bomb is the execution of the payload. محمد, why you coming late? The same way like the rootkits, actually the logic bombs, they are actually available and to run on the computer, whether the operating system, not like the rootkit on the motherboard, on the CMOS and BIOS. Now here it's in the operating system. It's a sort of a backdoor. It's a sort of textual file. It's a simple, let's say, scripting file. It's extremely small. Because of the size and because of the nature of this file, it is not easily detected. Security appliances will consider that this sort of resource or computer program is safe, yet it is not. This behavior is that it gives access to the attackers to where they are actually planted or injected. And they do not actually do anything unless there is a trigger. Unless there is a trigger. What does it mean? It means once the time comes, the payload will be executed. And it would cause what it is intended to do. Backdoor. So the conclusion, the backdoor is, the logic bomb is a simple backdoor, and the backdoor is a simple text file. It's textual file, not text file, textual file. Scripting file written in JavaScript and C++, and something similar. But might be actually extremely small in size. And this extremely small file, it is not easy to detect because of its nature. It's textual file, so the antivirus, they will not suspect it's a malware. In so many cases, it would be successfully running within the environment. Privilege escalation. Actually, in this regard, here we are willing to. Actually, I believe that we explained this part, but I don't know. I don't know why I'm thinking that we explained this part. Did we finish this part, please? Can you just remind me? Regardless, very quick, I'm going to pass through. The privilege escalation is a context of gaining the right of a higher privileged user, in the sense of if you are willing to hack an account, from the techniques you have to think of is the privilege escalation, is to get a higher privileged account. For example, if I want to actually open the database of the, let's say, EduWave, I have to be an administrator. So I have to get the privilege of an administrator. Thus, I have to think to escalate the rights or the privileges of the administrator to my rights in order to use them. So privilege escalation is a matter of transferring higher privileges to my account, to my actually session. Privilege escalation, more or less. Sort of, let's say, a malware, which is actually a communication platform, a spam nominated, which is actually an undesirable email or an unsolicited email. It is a context of a media communicated over the mail platform, but it is not wanted. It is not wanted due to its content. Mainly, it tries to circumvent a user. Mainly, it tries to circumvent a user in the sense of trying to thieve him or rob him, or let's say trick him to thieve his credentials or whatever he has actually as data. The content of spam, it's a normal email. It's a normal email at the end of the day. There is textual content and there is graphical content, either this or that. Once it is textual content only, it is easy to detect and to say that it is a spam or not. But once it is holding an image inside, and especially if the image holds text or links even, it is not easy to detect. Because the filters working behind, filters working behind to block the spams or to detect the spams, they are actually normal email filters. So they will not be able to easily scan images. Those are some considerations how a spam would be actually controlled or blocked. Another kind of, let's say, Trojans steal, and they are actually computer programs classified as malware. The spyware mainly. A spyware is a sort of computer program that tries to eavesdrop, gets information monitors with only a static behavior the traffic in order to get knowledge, no more no less, just to get the knowledge. It does not destroy. The spyware does not destroy. It does only thieves knowledge. It gets only a copy. It gets only data to be exposed only. This is actually classified as spyware. Why? Because it is violating clearly the privacy of a given individual. Otherwise, they are simple monitors. If they are not breaking the privacies. They are network monitors, or let's say computer monitors. Monitor. They control only. But since they are violating the privacy without giving any hint and without asking permission or consent, so they are spyware. Okay, those spyware actually they are still having the solution is we can actually avoid them, we can detect them, we can block them using the anti-spyware technology, or let's say classified technology. And then here actually it is sort of just detecting whomever process is trying to get in without a consent. If any process trying to get in without a consent, so it would be detected by the anti-spyware. Okay. They are easy to spread. They are easy to spread. The spyware in general, they are easy to spread, and they are set for the purpose of making profit. So they try to get copies of data, that try to get actually knowledge about a given framework or something like that. For what purpose? Is the profit now? So if I expose your password, I will not give it back, or I will not delete it unless you pay money. So this is a profit. It's a kind of a profit, something like that. So they are intrusive in the sense of they get into an environment without giving any hint and without asking for permission or consent. And because of this only, if they succeed in intruding, there would be actually it would be actually difficult, very difficult to delete them or to detect them. Same scenario like the logic bomb or the rootkit. And since they actually have those capabilities, they are not easy to detect, even with an antivirus. They are not easy. It means actually the antivirus do not expect that the antivirus will detect every and each single spyware. No. Spyware, they are classified into two groups. Spyware, they are classified into two groups. Either they are adware or keyloggers. Either they are adsware or keyloggers. They come to your computer in one of the two forms. Either they are sort of an advertisement, like this window here. We are opening the email, but we get this window. So this is actually sort of an advertisement. And it might bring to your computer another a spyware. If they are only checking, if they are checking, not only, if they are checking your type of operating system used, your IP address, the browser you are visiting, the website you are visiting, and so on. So they are spying on you. Advertisement. So they are spyware. Example of a spyware. The effects of a spyware, actually, I believe that we explained this one, but even though the effects of spyware, actually, mainly they are going to cause some of the issues. They do not destroy, but they actually cause latency in processing, probably to be slow. They can cause actually a system to be really unstable in the sense of you are opening a browser, it does not open, or it keeps loading for a very long time, so it's not stable. Actually, they can install new toolbars, new functionalities in your browser, toolbars in your browser specifically. They may generate shortcuts on your desktop, your computer desktop. They may do that, absolutely. They may change the home page of your browser. They can do that, absolutely. The browser actually you used to open and you find the Google, the first page. No, they may change to another URL. They may, and because of those facts here, they may cause extra advertisements would come to you, more and more and more. Good. The second category of the spyware is the keyloggers in plural. The keyloggers, they are sort of keystrokes followers. They do follow all what you type in your keyboard, all what you do type in your keyboard. They are a very and tiny, small computer program. They are not big to talk about them. They are simple, let's say, textual file that has the capability to run and record all the keystrokes you as a user on your keyboard. And more than that, actually, they are not the unique tools classified as keyloggers, because there are hardware classified also as a computer program, classified as keyloggers. So converters like this one we see here, it might record all the flow you send or you receive and send it to a remote attacker's computer. So keyloggers, in conclusion, they are either software or hardware. They can be both. Yeah, all the recorded, let's say, keystrokes, or what has been recorded by the keylogger, or the logged data, would be communicated with an external attacker. Absolutely. We were talking about the logic bomb. The logic bomb basically is a backdoor that runs according to a logical process, which is the time mainly. And one logic bomb, if it is injected into a computer, that computer is a zombie. And the zombie is a compromised device. A zombie is a compromised device. What does it mean? It means actually it is a computer that an attacker can control remotely. And the group of zombies of the same attacker, they create a botnet, one single botnet. There might be 100,000 million of computers remotely controlled by the same zombie, which is a program, one attacker has been generated. Sharing backdoors, or let's say zombies or compromising devices, it needs actually a technique how to. The best approach attackers do or follow in order to inject that backdoors is the social media platforms. Example given to us here is the IRC, which is the relay chat, let's say, engine, internet relay chat engine, which is a social media like the Facebook, like the Twitter, like the WhatsApp. All of them, they can help share malware, logic bombs. And if you are victim into a logic bomb, so your computer is a zombie or your device is a zombie, means it is a member of a botnet, means it is controlled by a remote attacker. Exactly what we were doing. What the botnet actually can do, one botnet, شبكة الروبوتات in this SaaS. What can do actually, so many activities they can do actually using those compromised devices. They may actually send emails from the compromised device without permission. Here we nominated spamming. They may actually send and expand the network of the botnet by spreading malware, by resending the logic bomb or the backdoor, the zombie again and again and again to compromise more devices. They might, those botnet, the zombies within a botnet, they might actually infect the full social media, IRC, internet relay chat, actually, like the Facebook or the IRC itself. This is an old chat platform, or any similar social media network. They might actually be utilized for making votes and polls. Manipulating polls means 1 million zombie in a botnet. They might visit the website in just one click. 1 million visits per second, or let's say per minute. This is a huge number. So this is a sort of a poll, electronic voting. They might cause denial of service, in the sense of they might actually attack the server in order to make him be occupied. The server just receiving requests from the botnet again and again and again and again. And anybody else tries to access the server or to receive a service from the server, it would be actually denied. So we talk about denial of a service or denying a service, denial of service. Great. The malware we are classifying so far, they are not hardware, they are not software only. We saw an example of the Keyloggers as a hardware, but even though malware, they are not only a computer program issue. They are not only because of the computer program, but there are hardware, also a question of generating or receiving malware or being attacked by a malware. The regular understanding is that if a malware is injected into a computer, what it will do? It will infect or conceal or hide. In the sense of they will attack an operating system or an application software or system software. That's what we know regularly. Yet here we see that a virus or a malware or a Trojan, malware in general, whatever it is, it might attack a hardware, not only a computer program or a computer system software. The first example of the hardware that might be attacked by a malware is the BIOS, the basic input-output system. It's the OS available on top of the motherboard, responsible for controlling the input-output peripherals. BIOS. Ordinarily, actually, the BIOS was just a sort of a ROM chip, in the sense of it can be only read, it cannot be actually altered. But nowadays, computers, they are presenting PROM, in the sense of programmable read-only memory, means this read-only memory can be programmed and rewritten again and again. So a BIOS actually on top of a computer nowadays, newly set computers, it might be actually changed now, reprogrammed. Thus, this is a vulnerable point where malware can act. They may actually cause commands to be reprogramming a BIOS function, something like that. Yeah, and once a malware succeeds in changing or in attacking a BIOS because of it is a PROM architecture. PROM actually it's an architecture built on top of a PROM, let's say, architecture that would actually overwrite the content of the BIOS. It can completely be overwritten. Completely, yes, it can be. A virus on like the rootkit, actually, we were talking about the rootkit that it attacks the BIOS or the CMOS. Still here, actually, we are talking about the BIOS attack. So the virus available in a BIOS would not be detected by the antivirus. A virus available on the BIOS, let's say a virus available in the BIOS, the ROM or the PROM, it would not be able to be detected by the antivirus, whatever the antivirus is. Why? Because the antivirus is on top of the operating system, yet the BIOS virus is down of the operating system, it's on top of the motherboard. They are not on the same layer at all, so they cannot see each other. And since the ROM is programmable and it can be actually rewritten, like the malware has done, it rewritten the content, it reflashed the content of the ROM. So to cure the computer from such malware, we need to reformat the ROM itself. What the malware has done, we have to redo it again and again in order to be sure that it is not infected with a BIOS virus. BIOS virus. Hardware responsible for actually carrying malware, USB drives, the flash disks. Those are sort of flash memory holders which are actually able to write and rewrite and change and rechange and to edit the content of their inner memory. USB drives, they are actually sort of a hardware vulnerable to different malware attacks. Because of its wide usability, it is one of the very catastrophic devices that has to be actually controlled again and again and again. Widely used because it's very fruitful as per its service. Example of malware on hardware. Examples of names only. Okay, constraints to push us to secure against malware that they attack the USB device are three groups. I classified into three groups. Or three activities you can do. Either the USB ports in your computer, you disable them. The USB ports, you open the case or whatever you have, and you disable the hardware itself. You take off the wires or USB drives, you just disable them. This is the one of the securities that you may go for. The second option is that using the device manager in your operating system to block or to disable USB drives from the operating system level. A third solution is that you install a third-party software, or you follow a third-party software capable of controlling your USB drives, USB actually access points. Any questions so far, please?
No, Mr.
From the hardware, also one of the technologies that it is capable of ameliorating the life of the, let's say, administrators is the architecture of storage. Because we are dealing with computer networks, so we are given remote services and we are helping users to share data. So the storage of the services or the resources to be shared, it's a context of security. There are two scenarios via which the storage architecture is set. Either the one we are seeing here, the network attached storage, means we are going to attach so many storage servers or file servers within the computer network or the environment. Only one. We will connect many servers dedicated to the storage only, where across the network, it's not in one location, across the network. This is said network attached to the storage, this technique. So whenever we need an extra storage space, we will attach it to the network in any new place. You don't have to worry about that. NAS. The second context, the second scenario is a little bit different. We are going, actually, example of NAS, we are going to create a dedicated area for storage only within the campus or within the network in question. Do not wait for another to come. In order, we need only a dedicated space where with an equipped and capable devices to store data, however the size is. We are talking about the storage area network. We are talking about the storage area network. The difference is that between the NAS and the SAN is that the network actually we need the network attached to the storage is that whenever we need a new and an extra space for storage, we attach a new device in any place within the same framework. Here no. Here no. We talk about a dedicated space. We have a room dedicated to storage only. So if you wanna have extra space, you attach a new storage device in the same location, not in any area in the network. No, in the same location dedicated for storage only. Yeah, a small comparison between this and that. Okay. Mobile security is one of the concerns that we have to talk about. The digital security still consider the mobile framework as context of security or digital security. Says the mobility is one of the actually luring features. If you are actually able to have a mobile device to serve you whenever you need, so this is much more attractive. Use a mobile better than a laptop or better than a desktop. And this is due to the mobility only. You'll have the chance to access your services and your resources whenever you want, wherever you want. So this is much more attractive. The same scenarios of, let's say, of attacks and threats. By a threat in a computer would threaten a mobile device. So the same scenarios of threats, threatening an operating system would threaten a mobile device very easily. It's the same context that we have an operating system, we have software application, we have system software. Okay. Another scenario here which we see, this is the last actually I'm going to discuss in this unit, which is the virtualization. Here it is, at the same time, it is a scenario that raises up the security against the available malware or the discussed malware, yet it isolates an environment. Means we are going to generate an isolated environment that cannot actually have access to any external resources unless given the permission. It has to be readjusted. The virtualized environment, like the VMware we are installing in the lab, that is helping to generate a virtualized environment, which is a sort of an isolated environment that emulates fully the hardware available. It takes the same capability of your computer, of your hardware computer. Virtualization is the context of emulating the hardware. Operating system virtualization is the at the level of the operating system, because your virtualization can be on top of the hardware or on top of the operating system. It means it's software to install inside the operating system, like the VMware we do, or it's software to run on top of the hardware immediately, the hypervisor. We talk about hypervisor. So this or that, it depends on the context of the question requirements. Yeah, emulator to emulate the real hardware. Para-virtualization, actually, it's a context of having a specific task to do. We are going to virtualize to have a specific functionality. We are not having the full operating system functionality. It's a hook. It's a hook. Full virtualization is another emulation of the environment. It means we are going to have the full capability of a priorly determined operating system. The operating system level of virtualization, it's a context of virtualization is still emulation of the environment still, because we will have the chance to interact with the operating system itself. And the example is the VMware, not the VMware. The VMware is not an operating system virtualizer. The one from the Microsoft, actually, I've forgotten the name. I'm sorry. Regardless, it is a feature to be activated from the operating system only, or to be disabled, either enabled or disabled. Okay, by this actually we come to an end of this unit. If you hear your name, please say yes. I'm going to stop the recording.